This is Leetcode 129, sum root to leaf numbers. Let's look at this example. So the question says, given a tree like this, root to leaf numbers are going to be 4, 95, 4, 91, and 40. So these three numbers added together is going to be 1026. And you're asked to return the sum of all of the root to leaf numbers given a binary tree. Okay, I think upon seeing this problem, you need to ask yourself one question. What type of tree traversal is going to give you such numbers, such root to leaf numbers? For example, 495, 491, and 40. It's going to be pre-order traversal. So this is clear. We're going to use pre-order traversal in our DFS function for this question. So in our code skeleton here, we will must have a DFS function. And if we're not sure about the return type for this function, we can leave it void here and we can change it on the go. And we're going to traverse on tree node. If we have a recursive function, we're going to have terminating conditions. And we said we're going to use pre-order traversal for this tree. So we will handle current level first. After that, we're going to recurse on left and right. Now the key point in this question is when we're at the leaf node. If I'm the leaf node here, not only do I need this value 5, but I would need 495. How do I get 490 from my parent? By using an argument. So in the DFS function here, I'm going to ask my parent for its current sum. So if my parent, 9, gives me 490, together with my own value, I'm going to have 495. I would also add 495, which is my value, to the result. So we're going to have a class variable here. Then in this DFS question, if node is equal to null, we simply do nothing. As we said before, in current level, we're going to take care of leaf. So if the node is leaf, I will increment result by currSum. And it seems like we need to prepare currSum before we even get to this line of code. So in current level, it's going to be currSum I got from my parent multiplied by 10 plus myself. Now guess what happens in this tree? Starting from 4, we give currSum equal to 0 for 4. So the root node's currSum is going to be 0 times 10 plus 4, so it's 4. It gives 4 to its children. 9 gets a 4 from its parent and it multiplies 4 by 10, so it's 40 plus 9's value, so it's 49. And finally at 5, 5 gets 49 from its parent and 49 multiplies 10 plus 5. It's going to be 495. And then we can safely call left and right for DFS function. Seems like we're done with the DFS function and we can call it test. So in our solution, our time complexity is going to be simply O of n, because in this tree we traverse node by node. Each node gets met by one time. Our space complexity is also going to be O of n, because in this call stack, DFS is going to create a call stack for every node. So we're using O of n auxiliary space. Okay, that's all for this question.